Today's topic is polar equation. So as we know, in Cartesian coordinate system, when we represent a point, we denote it by x and y. That means if this point is px comma y, then this length will be x and this length will be y. This is called Cartesian coordinate system. Similarly, we have polar coordinate system, which is denoted by r comma theta. That is, here there will be one initial line, one axis, which is known as initial line. And suppose we want to represent a point P by r comma theta, then this distance OP will be r and this angle will be theta. This will be our pole or origin O. So by r theta, this is called polar coordinate system and this is called Cartesian coordinate system. What is the relation between them? X equals to r cos theta and y equals to r sin theta. Now using this r theta, we will represent few standard equation of mathematics. First one is polar equation of a straight line. Suppose we have, this is O pole and this is the initial line OX. This straight line, we want to find its polar equation. So we will choose one point r, suppose r comma theta, then this length will be r and this angle will be theta. Then from that line we are drawing a perpendicular from that pole to that line, naming it as n. Suppose this length is p and this angle is alpha, then its coordinate will be p comma alpha. Then the equation of that straight line will be r cos theta minus alpha equals to p. This is the standard equation of a straight line using polar coordinate system. R cos theta minus alpha equals to p. Okay. Next is polar equation of a circle. This is denoted by r equals to 2a cos theta minus alpha when the pole is on the circle. When the pole is on the circle, and what is denoted by a? A is the radius of the circle. So r equals to 2a cos theta minus alpha. Whenever you will get this equation, you need to understand that it's a circle. Now in general, how will we find out the polar equation of a conic? Polar equation of a conic. So in that case, we will choose the pole O as the focus. Suppose we are considering either parabola or hyperbola or ellipse. Suppose we are taking this ellipse. This is one focus, this is another focus, S and S dashed. We will choose one of the focuses like this one as our pole, that is O. Then what will be the, this will be our initial line. Then what will be the equation using polar coordinates? So the general form of the equation is L by R equals to 1 plus minus E cos theta minus alpha. Either plus or minus, both can be taken according to the direction of the initial line. So L by R equals to 1 plus minus E cos theta minus alpha. So what is L? L means the length of semi-latus rectum. I hope you all know what latus rectum is for a parabola or ellipse or hyperbola. So this is the half of the length of the latus rectum. This is denoted by L, and r theta are common coordinate system for polar coordinate system. So whenever you get this equation L by R equals to 1 plus or minus E cos theta minus alpha, then you need to understand that it's a conic. Now according to the value of E, we will define that what type of conic it is. So if E equals to 1, E means eccentricity, then it's a parabola. E less than 1, then it's an ellipse, and E greater than 1, then it's a hyperbola. Okay, so according to the value of E, we have to find out what type of conic it is. Now there is also another form of a straight line in polar equation, which is 1 by r equals a cos theta plus b sin theta. Already we learned another form of straight line, which was r cos theta minus alpha equals to p. This is another form. You can get from one form to another form easily just by some simple calculation, where capital A and B are the constants. Now whenever you get such type of equation, that is 1 by r a cos theta plus b sin theta, you need to understand that it's represent a straight line. Okay, and next one is equation of a tangent of a conic. Equation of a tangent of a conic. It is denoted, suppose the conic is L by R equals to 1 plus e cos theta. Here the value of alpha is 0. This is our conic. Then its tangents equation will be L by R equals to e cos theta plus cos theta minus alpha. Okay. So this equation is, whenever we need to take any equation of a tangent, we will choose it like that. L by R equals to e cos theta plus cos theta minus alpha. Okay. So this was the theory part of that chapter, polar equation. I just state very briefly only the main points and what you have to memorize. Okay. So now using that formulas, we will apply it for problem solving. So starting with problem solving, example 1. Find the nature of the conic 8 by r equals 4 minus 5 cos theta. 8 by r equals 4 minus 5 cos theta. So the form is L by r equals to 1 minus e cos theta. So this one should be 1. So what we will do, in the next step we will take common 4. This 4 and 8 got cancelled out, so we get 2 by r equals to 1 minus 5 by 4 cos theta. So if you compare it with L by r equals 1 minus e cos theta, then you will get e takes the value 5 by 4, which is clearly greater than 1. That means it's a hyperbola. So the given conic represents a hyperbola. Okay, this type of examples are important for short answer type questions. Next one, I am stating very briefly only that part you need to understand for exam, only for the exam purpose. I am not going in the details of anything. Okay. Example 2, find the points on the conic 14 by r equals 3 minus 8 cos theta, whose radius vector is 2. That means in polar coordinate system we denote one point by r comma theta, right? R is the radius vector and theta is the angle. So here r is given, r equals to 2. So we have to find out theta. That is, find the points on this equation, whatever it is, a conic whose radius vector is 2. So let's find out, putting r equals to 2 over this equation. This will give you 7 minus 3 equals minus 8 cos theta. This 4 by 8, that is cos theta equals to minus half. So theta would be 2 pi by 3 or minus 2 pi by 3. Right? So these are the values. That means the points are 2 comma 2 pi by 3 or 2 comma minus 2 pi by 3. Okay, so this is how, if r is given or either if theta is given, we have to put one of the values in the equation and get the other value, the other coordinate, to find the polar form of that points. Okay, next example 3. Find the polar equation of the ellipse. Find the polar equation of the ellipse x square by 36 plus y square by 20 equals to 1 if the pole is at its right hand side focus. If the pole is on the right hand side focus and the positive direction of the x-axis is the positive direction of the polar axis. So at first try to find out the diagram. This is the ellipse. This length is, if you compare it with the standard equation of ellipse, it looks like this: x square by a square plus y square by b square equals to 1. So here a square equals to 36 and b square equals to 20. That means a equals to 6 and b equals to root over 20, right? This length becomes a, that means this length is 6 and this length becomes b, so this is root over 20. And its right hand side focus is the, here are two foci for an ellipse. So suppose this is S, this is S dashed. Among the right hand side is our pole. So this is our pole and the positive direction is the axis or the initial line. So this is our pole S dashed and this is the line. We need to find out the polar equation. So at first, polar equation of a conic looks like L by R equals to 1 plus minus e cos theta, right? So we have to find out L and E. We know the rule, L is semi-latus rectum. What is its length? Latus rectum length is 2b square by a for an ellipse. So it will be half of 2b square by a, that is b square by a. Put the values, b square is 20, a is 6. The length will be 10 by 3. Next we have to find out the eccentricity. Finding the eccentricity rule is b square equals to a square into 1 minus e squared. You have already learnt about that rule in the chapter ellipse, which we have read in 11th or 12th standard. So from here we know all the values, b square, a square. Putting it, we are getting that e equals to 2 by 3. So check, this is already less than 1. For an ellipse, e is always less than 1. Now put that two values over this equation. You will get the polar equation of an ellipse. Okay. So putting it, L by R equals 1 plus e cos theta. So L is 10 by 3 by R equals to 1 plus 2 by 3 cos theta. Now simplify it a little bit, cancel that 3 and 3 all, then you will get the required polar equation for an ellipse. Okay. Next one, example 4. Show that the straight line r cos theta minus alpha equals to p, r cos theta minus alpha equals to p, touches the conic L by R equals to 1 plus e cos theta if L cos alpha minus EP its whole square plus L square sin square alpha equals to p square. So we have to prove that this straight line touches the conic this if this condition is satisfied. So touches, that means somewhat suppose if it is a parabola, look like this, that means this straight line touches the conic, that means this straight line becomes a tangent of that particular conic. L by R equals to 1 plus e cos theta. Now we know how to take an equation of a tangent for polar coordinate system. So we will choose that let the equation of the tangent is L by R equals e cos theta plus cos theta minus alpha, right? That was the equation of a tangent, but here alpha has already been used in the question, so we cannot use alpha anymore, we will choose beta. So this is the equation of the tangent. Now opening that bracket, cos a minus b, which is cos a cos b plus sin a sin b, so e cos theta. Okay, then taking cos theta also common, so we are getting this value. Okay, naming it as equation number 1. Similarly, we have that straight line given which touches the conic, that means it becomes a tangent. So taking the equation of that straight line, r cos theta minus alpha equals to p, then it will take the form p by r equals to cos theta minus alpha. Now opening the bracket, cos a cos b plus sin a sin b. Okay, naming it 2. Now 1 and 2 are equivalent because it touches the conic and it's a tangent. Both means the same. So we will compare 1 and 2. Compare means we will compare the coefficient of cos theta and sin theta. So left hand side should be same. That means P by L equals to the cos theta's coefficient here is cos alpha. And here cos theta's coefficient is E plus cos beta. Now here sin theta's coefficient is sin alpha and here sin beta. Okay. Now take this one and this one. From here we can get the value of sin beta. What will it? It will be L sin alpha by P. And if you consider this one and this one, we can get the value of cos beta, which will be L cos alpha by P minus E. Just by cross multiplication you will get the result. Now we know a relation between cos beta and sin beta, that is sin square beta plus cos square beta equals to 1. Put their values, L sin alpha by P its whole square plus L cos alpha by P minus E its whole square equals to 1. Just simplify it a little bit, you will get the condition given in the question. That is, this is the required condition for being that straight line become a tangent of that particular conic. Next, another example 5. Show that the semilatus rectum of a conic is a harmonic mean between the segments of any focal chord. Show that the semilatus rectum of a conic is a harmonic mean between the segments of any focal chord. So what is harmonic mean? For two numbers, suppose it is A and B, harmonic mean is 1 by A plus 1 by B. Sorry, half of 1 by A plus 1 by B. So this is the harmonic mean. So okay, we have to prove that the segments of any focal chord. So suppose this is our curve, this is the focus, this is P, Q. So focal chord means SP and SQ. That means we have to prove 1 by SP plus 1 by SQ equals to half of this whole thing equals to 1 by L. L means semilatus rectum. So okay, taking that value, this is our pole. So this, if this length is r and this angle is theta and this length is r dashed, then this angle is pi. That means what will be, so if SP equals to r and SQ equals to r dashed, then the angles will be r comma theta and r dashed comma pi plus theta, right? The points P and Q. Now we let us choose the conics equation is L by R equals to 1 plus e cos theta. Then putting the value r comma theta, we are getting this result, and if you put this value, we will get L by R dash equals to 1 plus e cos theta plus pi. That means 1 minus e cos theta. Okay, this one and this one. Now put their value. This is our SP and this is our SQ. So just take 1 by SP plus 1 by SQ. Calculate it, you will get the result 2 by L. That's it. Okay. So here L becomes 2 by 1 by SP plus 1 by SQ. That means harmonic mean of that focal chord.